Alright, 2024 CSSA Maths Extension 1 trial paper review. Let's begin straight away. Question number 1. Coefficient of x cubed in the binomial expansion of 2x minus 3 to the power of 7. So, the expansion is given by sum of terms that's got the structure 7CR. First term 2x to the power of 7 minus r multiplied by second term negative 3 to the power of r. Now the actual expansion itself is given by the sum of these terms starting from r equals to 0 up to r equals to 7. Of course, we don't need the entire sum. What we need over here is we just need this bit that we call the general term, don't we? And in particular, we want to split out the coefficient like I've just done. Essentially what I did is this term in the middle, 2x to the power of 7 minus r. I applied index laws to split that up into 2 to the power of 7 minus r. And of course I would also need x to the power of 7 minus r, which I will write at the end of the term, of the expression. Okay, the index law applied there is a times b to the power of n is equal to a to the power of n multiplied by b to the power of n. Okay, and for the x cubed term, which the question is looking for, I need this power on my x of the general term to be equal to 3, of course. That means 7 minus r is equal to 3, which of course means r is equal to 4. And when r is equal to 4, the coefficient, which would be this part, would equal 7 C4 2 to the power of 7 minus 4, so therefore 3 minus 3 to the power of 4. And that goes inside the calculator. And from there, the correct answer is D, 22680. Okay, moving on to question number 2. Simple differentiation question. So, derivative of inverse sine is given by 1 over square root of 1 minus. And if it is the derivative of inverse sine x, you would have x squared under that square root, like that. But instead of inverse sine x, as we can all see, we have x on 2. So I would also have x on 2 instead of x in my derivative. I also had 2 at the front that needs to be multiplied in the derivative as well. And I also need to multiply this by half. And half here is the derivative of x on x over 2, isn't it? Essentially, I'm applying chain rule. To find the derivative over here, and well, the answer is this simplified. So you can begin that by canceling the 2 and the half, right? And yeah, some simple algebraic calculations would give you D again as your answer. Moving on to question number 3. So this time the standard deviation of the sample proportion essentially is what they're asking. Now standard deviation is defined as the square root of the variance, here the variance of the sample proportion. And the variance is given by the expression p times 1 minus p over n. Now, what's the p and what's the n in this question? Well, both of those numbers are directly stated in the question actually. P is the 30%. In other words, 0.3. And the sample size n is the number of people surveyed. That's 50, isn't it? So you substitute those numbers into the expression that you have. So you would have square root of 0.3 multiplied by 0.7 divided by 50. And once again, that just goes into the calculator and your answer is B. Next, question number 4. Graph of y equals to f of x is shown. Which of the following is the equation of the function? Now, I've emphasized to my students multiple times in our classes that when you get a question of this type as your multiple choice, I told you guys that the safest and the easiest way to work out the correct equation is to just simply substitute in the coordinates of a few points that the equation should satisfy. Didn't I? So what I'm talking about for this particular example is we know from the given graph that the graph passes through, for example, pi on 2, 0, don't we? We also know that the equation of the graph should satisfy this point up here. 3 pi on 2, pi is what it appears to be, doesn't it? Now, your selected points doesn't necessarily have to be these ones which I picked, right? It's just so long as it's any point that lies on the graph given, the equation, the answer that is, of f of x, equation of f of x should satisfy, well, when you substitute in the coordinates of that point into the correct answer, all those points should satisfy is the point that I'm trying to say. And essentially, you substitute these points into each of the options available one at a time, okay? And you keep the ones that do satisfy, you eliminate the ones that do not satisfy, right? And, you know, after subbing in one particular point, if you're still left with multiple options, then you substitute in a different point, okay? And of course, you would use your calculator for that. Okay, you keep on substituting in different points until you eliminate everything and you are left with one answer, and that one answer is the correct answer. That's the easiest and the simplest way to get this done. However, that said, if I were to give an explanation on this question, I guess, well, I've chosen to explain it. That is, you know, if I were to give you an explanation of another way, of a different way than just to sub in points, you know, to solve this question, I've chosen to explain it using the domain and the range of f of x, because it is evident, it is pretty clear from the graph that's shown to us that the domain of f of x is all real x, and that its range is from 0 to pi. Minimum 0, maximum pi, isn't it? And yes, when I say that I am gonna use this to solve the question, I'm saying I'm essentially gonna pick the equation out of the options, I'm gonna pick the equation that's got the same domain or real x and the same range from 0 to pi. And with that said, I can then begin by eliminating options C and D. Why? Because if you look in C and D, you have inverse sine x and inverse cosine x, don't you? And what you learn in your syllabus is that x inside inverse sine or inverse cosine is restricted. It's actually restricted. It's restricted to be between -1 and +1, isn't it? Okay, so if C and D were your answers, then your graph would have its domain restricted between -1 and +1. Of course, that is not what is shown in the question. That is not reflected in the graph that's given in the question. So C and D cannot be the answers, right? And out of the two options remaining, A or B, you can eliminate B through the range, okay? Because if you look at B essentially is a function of this structure, isn't it? Sine inverse, and then inside, yeah, I know with option B, it's the g of x is cosine x, but I'm saying generally it's sine inverse of some function of x inside, right? Essentially, I'm saying option B is a composition of sine inverse function and another function inside. That is what I'm saying. Now, for these types of functions, the range of y takes a minimum of minus pi on 2 and a maximum of pi on 2. Okay, that is, I'm essentially saying when you take sine inverse of whatever number, right? Whatever number that may be, but you take sine inverse of some number, then the minimum value that you can get is minus pi on 2 and the maximum value that you can get is pi on 2. You learn this when you learn about domain and range of inverse trigonometric functions, right? But is that shown on the graph? Is that shown in the graph shown in the question? No, it's not. Why? Because the range of f of x shown in the question goes up to pi. Well, its maximum is pi, doesn't it, right? And of course, pi is bigger than pi on 2, right? You cannot get pi as an output value from a sine inverse something, okay? So based on that, again, B is eliminated, which then leaves A as your only answer. A, on the other hand, is composition of cosine inverse, isn't it? It's cosine inverse of g of x, right? And again, from domain and range of inverse trigonometric functions, what you learn is that those functions, cosine inverse law, right, takes a minimum of 0 and a maximum of pi. And in fact, that is exactly what is represented in the graph given in the question. So that agrees with A being the answer, doesn't it? So that's enough of explanation of question 4. Now I'm moving on to question number 5. Px has a remainder of 2x plus 3 when divided by 4x squared minus 1. Now, once again, what I emphasized to my students is the fact that this sentence, when you read this sentence in an exam question, polynomial divided by something produces this remainder, right? That structure, you immediately rewrite that as, okay, P of x is divisor 4x squared minus 1 times the quotient, which we don't know what it is because that's not stated in the question, but I can just write that as Q of x plus remainder, which the question tells me is 2x plus 3. So once again, P of x polynomial is equal to divisor times quotient plus remainder, right? That's how we always write down, okay, if an exam question says polynomial Px divided by something produces this remainder. And then with that, we answer the question. The question is what? What is the remainder when divided by 2x minus 1? So the remainder when divided by 2x minus 1, they're asking you to find p of half. How do I know that? Remainder theorem, right? Half is the 0 of my new divisor 2x minus 1, okay? And p of the 0 of the divisor is the remainder according to the remainder theorem. How do I get p of half? Well, chuck half into the expression for p of x, which I have. And that actually makes this part. 4x squared minus 1 equal to 0. So regardless of what q of half is, that first term will just be 0. Plus I got 2 times half plus 3, which of course produces 4, doesn't it? So D is the answer to question number 5. Now, question number 6. 8 cards, each marked with a different digit from 1 to 8, are randomly placed in 2 rows of 4. What is the probability that odd-numbered cards are in 1 row? So essentially what I am doing right now is I am drawing those 8 cards, which, as you can see, are placed in 2 rows of 4, top row and a bottom row. And the probability that when cards numbered 1 to 8 are randomly placed in these positions, the probability that all the odd numbered cards are in 1 row. Now that immediately opens up 2 cases to consider for us. What are the 2 cases? When all the odd numbers are in the top row and when all odd numbers are in the bottom row, doesn't it? Okay, so I'll begin by considering one of those cases, which is when all the odd numbers are in the top row. Top row over here has got all the odd numbers. Okay. And again, in the question over here, the 8 cards are being randomly placed onto these positions. So for this first position over here, which I just put a tick on top of, you have 1 card being placed there randomly out of 8, but 4 of those 8 cards, 1, 3, 5, 7, right? 4 of those 8 cards are odd numbers, aren't they? Okay, so the probability, the chance of an odd numbered card going into that first position is 4 on 8, isn't it? Right? And then moving on to the second position over here, assuming that the first position has been taken by an odd numbered card because we need it to be, according to the question, then we now have got 7 cards to pick from, or 7 cards that, any one can be randomly placed into that second position. But out of the 7 cards, 3 of them now are odd-numbered cards, aren't they? Because one of the odd-numbered cards went into the first position. So again, if you think about randomly placing one of the 7 cards remaining into that second position, the probability that an odd-numbered card will fill that second position is 3 on 7. And then you get the idea, right? For the next position, the third position, 2 on 6. And then for the last position, 1 on 5. And all those probabilities multiplied then gives you the entire probability, all those probabilities multiplied then gives you the probability of the entire top row being filled by an odd numbered card, doesn't it? Okay. But again, that is the probability of just the top row being filled by odd-numbered cards. We also have to consider the case where the bottom row is filled by odd-numbered cards. But you guys get that the probability of the bottom row being filled by odd-numbered cards will be equal to the probability of the top row being filled by odd numbered cards, don't you? Because you could, the argument which I made, the explanation which I made for the probability of the top row being filled by odd numbered cards, you could make the same argument and you could give the same explanation for the bottom row as well. You just have to switch the positions of the two rows, don't you? Okay, so then the probability that any one of the two rows is filled by odd numbered cards, which is what the question is asking for, is actually then just this multiplied by 2, isn't it? Because you would add the probability of top row being filled by odd numbered cards with the probability of the bottom row being filled by odd numbered cards. You would add those two probabilities to get the answer to the question, right? But when you're doing that, you're essentially just adding two same numbers, okay? Which is equivalent to multiplying by 2, multiplying that number by 2. And when you do that, again, the rest of it is calculator's job, but you get B as your answer through that. You could have also solved this question by considering permutations and combinations of essentially different arrangements of cards, okay? However, in my opinion, I think what I did is probably the simpler approach for this question, okay? That said, now to 7 we go. Differential equation defined for t greater than or equal to 0 and y greater than 0 as, so we've got a differential equation given where k is a constant, and you got slope fields shown in options A, B, C, and D. Which direction field best represents the differential equation when k is greater than 0? Okay, so you got slope fields shown, and the curves which are drawn on the slope field are supposedly 3 solution curves, is what the question says. So based on that, which one best represents this differential equation? Well, let me then begin this question, guys, by actually obtaining the solution, or well, the general equation for the solution. The general equation for the solution of the differential equation. So I'm talking about using separation of variables, which, yes, would involve put all the y's onto one side. So 1 over y dy. Put all the t's on the other side. And then, as usual, integrate both sides. Integrate. Okay. ln y equal to primitive of cosine, sine, plus kt plus c. And in the question, we are given that y is a positive number, which means the absolute value that's currently placed on y, you can remove that. So ln y is equal to that right-hand side, okay? And to make y the subject, I will raise both sides to power of e, and then e to the power of ln cancel, giving you y equal to e to the power of this thing, doesn't it? And I'm sure you guys have done this multiple times in this topic. When you solve differential equations, that is, I'm sure you've done this multiple times, right? That e to the power of c can be split out. And you can write the general equation of the general solution as a times e to the power of sine t plus kt. Can't you? And of course, since, again, we know that everything right here, everything, okay, is occurring in the first quadrant, right? T greater than or equal to 0, y greater than 0, right? We would be talking about a being a constant but a positive constant, wouldn't we? And that's the equation of the general solution. And the reason why I obtained that, why did I get that? It's because now I just have the job, okay? I'm just left with the job of picking the option that shows the graph of y equals to a times e to the power of sine t plus kt. Which one of these best demonstrate the equation of this function? In other words, that's all I have to pick, isn't it? Okay. And to understand what the graph of that function looks like, well, it's an exponential function, but the power on it is trigonometric function plus linear function, isn't it? What did I say again? Exponential function, because you got e, but the power on it is trigonometric plus linear, isn't it? So let's have a look at that power, right? Trigonometric, your sine t, which looks like this, right? This is the graph of sine t. You got that plus your linear function kt, which should just be a straight line, but it should be a straight line with a positive gradient. Why? Because we're given again that. No, we are given that k is greater than 0, aren't we? Now, what does that look like? So sine t, guys, trigonometric function, right? Sine graph is we describe it as being a periodic function, don't we? Why? Because it oscillates about a mean position, okay? And essentially that oscillation repeats over and over and over again, right? For that reason, we call sine graph a periodic function, right? That plus you add to that a linear function that's got a positive gradient, right? And what you end up getting then, that is sine t plus kt, is then you get a function which oscillates because of the trigonometric aspect of it. But it oscillates about the straight line kt. That's what you end up getting. Okay, and then this function is what? This function is, for your solution, this function is the power on e, isn't it? Okay, which then gets you guys to think a little bit about exponential functions. Well, the thing about exponential functions, the aspect of that's the simpler part, that's the easier part. Why? Because exponential function is really easy. For exponential functions, just the greater the power is, the greater the function value is. And vice versa. The smaller the power is, the smaller the function value is. It's that straightforward, okay? So whenever the power is bigger, you'll just have a bigger y value, right? Whenever the power is smaller, you will just have a smaller y value is the idea, okay? And based on that, what we can deduce is, again, if we have a look at how the power sine t plus kt behaves as t increases, what you guys should note is the fact that the power sine t plus kt, it oscillates, guys, right? You can't say it always increases because there are sections where the graph actually decreases, doesn't it, right? It oscillates, okay? But over large interval of t, guys, over large intervals of t, right? That is, rather than just focusing on, one single oscillation, if you focus on a large interval of t over multiple oscillations, because the graph oscillates about an increasing line, right? Over multiple oscillations, the graph actually increases, doesn't it? This increases, but I'll once again emphasize, not for all values of t, right? Not for all t. Be mindful of that. Okay? But I'm talking over a large interval of t, large enough of an interval of t, the graph should have increased, is my point, okay? So over a large interval of t, then for my solution curve, the power should have increased. Now, of course, if the power should have increased for an exponential function, then the y value itself should also have increased over a large enough interval of t. Then, which one of the options show that? A and B don't. Why? Because A actually shows a decreasing trend, doesn't it? Over a large interval of t. Okay? B, on the other hand, shows what? B shows constant. Doesn't it? It's C and D that demonstrate the increasing value of y over a large interval of t that I explained, isn't it? So your answer then is either C or D in this situation, okay? And in order to pick out what the correct answer is what I'm gonna do is, once again, it's an idea that I demonstrated in one of the earlier questions already, okay? But the same idea can be applied to slope field questions, right? Okay, just substitute in points, right? And just pick the option that satisfies, the conditions that it should satisfy, right? So in particular, if you have a look at C and D, at t equals to 2 pi, the solution shows, at t equals to 2 pi, C shows a solution that's increasing at t equals to 2 pi, doesn't it? But D shows a solution that is stationary at t equals to 2 pi. Okay? Now, it doesn't have to be 2 pi that you select, right? You guys can select other point. You guys can pick 4 pi if you want. You guys can pick 6 pi. You guys can pick 0 if you want, right? 0 would be simpler, in fact, wouldn't it? Okay? But I just chose 2 pi because, 2 pi gives simple answers when you substitute it into these kind of trigonometric functions, okay? But what's the criteria over here? If C is the answer, then at t equals to 2 pi, my solution is increasing, meaning its derivative is positive. But if D is the answer, at t equals to 2 pi, my solution has a stationary turning point, meaning my derivative, once again, dy dt, is equal to 0. Okay? So what? Chuck in 2 pi. My dy dt, is cosine 2 pi, which is 1, plus k times y. Now, what do I know about k and y? K and y are both positive numbers in the question, aren't they? So my derivative is 1 plus a positive number multiplied by another positive number, which of course must be a positive number itself. So my derivative is positive, meaning my solution curve is increasing at t equals to 2 pi, doesn't it? So then based on that, what's the answer? The answer is then C. To question 8 we go. Given the function, what is the gradient of the inverse function? Okay, so this question's a question that can be solved really simply and really easily. If you know a property, if you know this property about gradients of inverse functions, then it's a question that actually can be solved really easily. But at the same time, that property that I'm trying to refer to is also a property that a lot of students kind of forget about, after learning it in year 11. Okay, so what I'm going to do is I'm actually going to begin by explaining that property itself first, and then I will show you guys how easily the question can be done, right, if you just knew about the property. Okay, so here's the property. That is, you guys know that, all of you guys know that the graph of a function and its inverse are symmetrical about this line, y is equal to x. Now, that's not the property that I'm trying to get you guys to recall. Okay, that's a property that a lot of students can actually remember very well, right? But so if you have the graph of f of x like this, actually, not the best example. This is probably the better example. Yeah, if you have the graph of f of x like this, then the inverse function, which is symmetrical about the line y is equal to x, looks something like this then, doesn't it? If that's f of x, then that's the inverse function graph, okay? And the actual property that I'm trying to get students to recall is that as a result, if you have a point on your function, if you have a point that lies on your function, so for example, in my example, I've got the point 0, 1. 0, 1 lying on your function, then you have this thing called a corresponding point that lies on your inverse function, and that corresponding point just has got the x and the y coordinates flipped around. In fact, that's actually the definition of inverse function, isn't it? X and y coordinates flipped around. So if you got, in my example, if you've got the point 0, 1 on your function, then you have the point 1, 0 on your inverse function. Okay? And what you learn about these points, you call them corresponding points, but on top of that, what you learn is that the gradients at these points that I'm trying to represent right now using tangents. Yep, there we go. The gradients at these corresponding points on a function and its own inverse function are actually reciprocals of each other. So that is, if one of these tangents have a gradient of m, then the other one has got a gradient of 1 over m. That's the property that I was trying to talk about from the beginning of the question, right? And basically, if you remember this property, then the question is really easy to solve, right? Now, if you don't remember this property, then the question can get a little bit difficult to solve, okay? But yes, remember this for the HSC, okay? So based on that property, gradient of the inverse function at 1, 0, well, that then should equal reciprocal 1 over gradient of f of x at the corresponding point, which is 0, 1, shouldn't it? And that's so easy to obtain. Why? Because that's just what you're essentially looking for is just 1 over f dash 0 then. Gradient of fx at the point 0, 1, you call that f dash 0, don't you? Okay. And that, well, what's f dash x? F dash x, derivative of this is e to the power of x, negative e to the power of negative x plus e. So what's f dash 0? 1 over negative 1 plus e, isn't it? Why? Because e to the power of 0 is 1. Correct? And where is that? That's B. Being your answer, isn't it? Okay. So yeah, the question, guys, is that simple if you could just remember this property. But like I said, it is a property that a lot of students kind of forget about. Okay. Remember it for the HSC. And also for the HSC, you need to be able to algebraically demonstrate, that is, show the proof for this property. Okay. It's another thing that I emphasize you guys should remember about inverse functions. Okay, and that is if you ever want to show something about the derivative or the gradient of inverse function, okay, you start from this. So as in, suppose, guys, f and g are inverse of each other, okay. Suppose f and g are inverse of each other. Well, then that means the composition of f and g. So f of g of x. You could also start from g of f of x. It doesn't matter, okay? One or the other, right? But the composition of function and its own inverse is just equal to x. You start from there, and then you differentiate both sides. So what? Like that. And the left-hand side, we have a composite function. I told you left-hand side is the composition of a function and its own inverse, didn't I? Okay. So the derivative of that would require the use of, I applied the chain rule there, didn't I? Right? F dash gx, and then multiply by the derivative of the inside function, which is g dash x. And on the right-hand side, derivative of x, that's simple. Of course, that's just equal to 1. Correct? Such that g dash x is then equal to 1 over f dash g of x. And that, if I rearrange it, and that is the property which I explained over here, written down algebraically, isn't it? Why? Because therefore, things like g dash 1 is 1 over f dash g of 1, okay? But in the question over here, right, essentially I'm taking the inverse function as g in this algebra, aren't I? Okay? In this question, with this coordinate given, you know, with the question telling you that g of x, my inverse function, passes through 1, 0, they've given to you that g of 1 is equal to 0, haven't they? So from that, what do we get? G dash 1 is equal to f dash 0, don't we? And isn't that what we made use of to solve the question, right? G dash 1, gradient of the inverse function at x equals to 1 is equal to 1 over, so reciprocal of f dash 0, the gradient of fx at x equals to 0. Okay, that's the algebraic proof for it, algebraic way to show it. And again, that's also a thing that you guys need to remember and keep in mind. Okay, that's enough of that question. Now question number 9. Okay, this one was a fairly straightforward one. So the function that the parametric equations describe, I guess I can begin by obtaining its Cartesian equation straight away. So that would mean eliminating the parameter t. So I make t the subject in the first parametric equation. T is equal to x over 2a. And then substitute that into the second parametric equation to eliminate t. And I get y is equal to a times x over 2a squared, which simplifies down to x squared over 4a. Okay, and suppose, guys, that this is the equation of f of x. Okay, because the question then talks about dilating this function horizontally by 2 and vertically by 3, doesn't it? So the function that the question over here, well, I should say the dilated function the question is describing is 3 times because it's been dilated vertically by a factor of 3, f of, now the horizontal dilation factor was 2. So 3 times f of x over 2 is the dilated function that the question is talking about. Now, what's the expression for that? What's the equation for that in terms of x? Well, 3 times x over 2 all squared over 4a, isn't it? Which simplifies to 3x squared over 16. And the gradient of this function at x equals to a, well, differentiate this then. So 3x squared over 8a, that's the derivative. Sub in x equals to a, and then cancel. Something's gone wrong. Oh yeah, sorry. When you differentiate, my bad. When you differentiate, the power, of course, goes down by 1. So 3a over 8a at x equals to a, which is equal to 3 over 8, isn't it? And now the last question in the multiple choice over here. So, Lewis has a large set of 2 types of cards. One showing the direction vector 1, 0 and the other showing direction vector 0, 1. Okay. So you've got essentially cards that look like this. Cards that look like this. And question is, how many unique combinations of cards can be formed to describe a sequence of moves from the origin to the point m, n? Okay, so again, this is another question where if you have seen this type of terms and commas question before, which all my students have, okay, in my class, all my students have, because I remember teaching you guys this during our terms and commas lessons, okay? But Yeah, sorry. And if you have seen this type of question before, then the question is actually really straightforward and very easy. Okay, but again, it's a question where if you have not seen this type of pros and cons question before, then the question may have been a little bit difficult, right? So the idea is you're starting at the origin over here, and then you've got this point that's got the coordinates m comma n, where m and n are both positive integers, meaning that that point is going to lie in the first quadrant, isn't it? M comma n. Okay, and essentially the point of the question, what you need to understand about the question, okay, is that the two types of cards over here represent some kind of a move on the Cartesian plane, okay? And as to what kind of move they represent, it's really straightforward, okay? What kind of a vector? What vector is 1, 0? It's a vector that's got magnitude of 1 and a direction to the right, doesn't it? Okay, you also call it the I vector, right? What kind of a vector is 0, 1? Well, that's a vector that's also got a magnitude of 1, but pointing vertically up, isn't it? Right? So essentially, the two cards that you have is you got one card saying move 1 unit to the right, and you got another card saying move 1 unit up. And as to which one is which, I'm sure you guys got the idea, right? I'm sure you guys got the idea. You got those two types of cards, right? And using those two types of cards, right, you need to make a sequence of moves that takes you from the origin to the point m comma n, okay? So as in you can only move up or right, right? So you go, you know, up, right, up, right, up, right, up, right, okay? Yeah, and then until you get to the point m comma n, okay? That's the idea, right? Then if that's the idea, then for the combinations of cards, which the question is talking about, well, then there's only really one combination of cards you can have, okay? And that combination of cards I'm talking about is you need a set of cards that contain m of these cards that make you move 1 unit to the right, and you need n of these cards that make you move 1 unit up, don't you? Because from the origin to get to the point m comma n, you essentially need to move m units to the right and n units up, don't you? Okay, and given that moving to the right 1 unit and moving up by 1 unit is the only two types of moves you can make, right? Then the combination of cards that you need is that m of this card essentially and n of the other card, right? And that particular set of cards, that particular combination of cards is actually the only combination, meaning if the question truly and really meant combinations of cards, then the answer is 1. There's only one combination, right? Also then meaning that the question has got an error then, okay? The question really should not have said combination of cards, okay? Because what do you learn in pums and comps? When you say combinations, right, you refer to, in this case, when you refer to you refer to how many of each card. That's combinations, isn't it? Right? And it's in particular when you learn pums and comps, combination comps, right? You say order doesn't matter. matter, right? Regardless of order, okay, how many of each card, that's combination, correct? And if that's what they meant, there's only one. There's only one, okay? But is that what they meant? No, not really. So the question had an error. What did the question mean then? The question actually meant arrangements. That's what they really wanted to say, okay? How many arrangements of these cards are possible to describe a sequence of moves that go from the origin to the point m comma n. Okay, now that's a different story because ultimately you will still have m, okay, of the cards that make you 1 unit to the right and n of the other card that makes you move 1 unit up, okay. But you can, so the total number of each card would be the same, but you can arrange them in different order, can't you? As in, you can decide to move to the right first, you can decide to move up first. That's completely up to you, isn't it? Okay, and depending, and yes, that way you can get now not just one, but a number of different sequences of moves, can't you? Okay. Now, how do I get what the unique number of arrangements is then? This is the part where I said, if you've seen this type of question in Perms and Comms, then again, like you watching the recording would already know the answer to this, right? Okay, because it's that simple, right? You don't even need any calculation, okay? You don't even need any algebra. Like you should just be able to see the answer over here. The answer is B. C. You should just be able to see that the answer is C. Why? Because if you've seen this before, you would know essentially each sequence of moves is equal to each way of arranging these cards. And what I mean by these cards, I'm talking about the set of cards that's got m of 1 unit to the right and n of 1 unit up. Okay? Now, what happens when you arrange them? When you arrange them, okay, a possible arrangement that you could get is, for example, you could end up with, up first, right? Followed by right, and then up, and then right again, and then so on is one example of an arrangement of these cards, isn't it? Now, what does that describe? It describes, guys, a sequence of moves where you what? Move 1 unit up first, and then you go 1 unit to the right, and then what do? You move 1 unit to the right again, and then what do? You move 1 unit to the right again, because you had U, R, right? And then now what? Now you move 1 unit up, like this, and then 1 unit to the right. And then ultimately, because this sequence is gonna contain m cards that make you move 1 unit to the right, okay? And you're gonna have n cards that make you move 1 unit up. So I'm saying you got m of these moves and you got n of these moves. Because of that, when by the end of the sequence, right? By the end of the sequence of, you will end up at the point m comma n. Why? Because you would have moved m units to the right and n units up starting from the origin, wouldn't you? Okay, that's the idea, right? Now, why then is the number of ways of arranging these cards is equal to C over here? Because the number of ways of arranging these cards, guys, is essentially like, look what you have over here. You have U, okay? How many of that? You've got N, right? It's the same thing as the number of ways of arranging, guys. A, dot, 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 and you got m of these. B, dot, dot, dot. You got n of these. It's the same thing as that. In other words, it's the same thing as number of ways of arranging letters of a word, essentially, but you've got repeated letters. It's the same situation as that. How many letters or how many cards do we have altogether? Well, we've got m plus n cards altogether, and the number of ways of arranging m plus n cards altogether is, of course, m plus n factorial. Okay, but that divided by m factorial, because we get repetitions due to m of the cards being identical to each other, and for the same reason divide by n factorial, and that's exactly what C has, isn't it? So like I said, you don't even need any calculations, right? If you have recognized, or if you picked up what I was trying to say, what I was talking about, okay, you would have got the answer straight away like 10-15 minutes ago. Okay, but yes, that is the end of the multiple choice. Now I'll move on to the short answer questions. All right, now moving on to short answer questions. Question 11a. It's solving a simple trigonometric equation. So we have sine 2 theta plus cos theta equal to 0. As I have always emphasized, with trig equations here, angles do not match. You got sine 2 theta and cos theta. So begin by matching the angles. To match 2 theta to theta, of course, 2 theta being double theta, you guys can think, we can think to apply the double angle formula. So 2 sine theta cos theta is the double angle formula for sine 2 theta equal to 0. Now, we see a common factor, take that out. And the two factors tell us that the equation can be reduced down to either cos theta being equal to 0 or sine theta being equal to negative half. Doesn't it? And in the domain of theta stated in the question, that's between 0 and 2 pi. Cos theta equals to 0 gives two solutions, pi over 2, 3 pi over 2. And the other equation, sine theta equals to minus half, that also gives two solutions, 7 pi on 6 or 11 pi on 6, doesn't it? That's question 11a. Simple. Done. Moving on to 11b. Find the angle to the nearest degree between the two vectors a and b. Okay, so again, question 11 being question 11, simple question where you can obtain the answer by throwing numbers into a formula. The formula here that I'm talking about is the cosine angle between two vectors. So that's a dot b over magnitude of a multiplied by magnitude of b. Now a dot b, the dot product is x1, which is 3, multiplied by x2, which is negative 1. So 3 times negative 1 minus 3 plus y1, which is 1, multiplied by y2, which is 2. So 1 times 2, what is it? 1 times 2, 2, over, this all over. Now the magnitudes of each of the vectors, that's obtained through Pythagoras' theorem, isn't it? So magnitude of A is the square root of 3 squared plus 1 squared, multiplied by magnitude of B is minus 1 squared, or 1 squared, plus 2 squared. Now, that goes into the calculator, and in order for you to find the angle theta to the nearest degree you take cosine inverse of that right hand side, and to the nearest degree in the calculator it gives 98 degrees. That's it. That's 11b done. Now 11c. Solving the inequality over here, again, you guys could decide to multiply both sides by x minus 1 all squared, which, yes, that's the square of the denominator over here. And then you would get a quadratic inequality in x, which you can solve to obtain the solution. But I'd also like to demonstrate this through considering cases. So because we got x minus 1 on the denominator, of course x cannot be equal to 1. But now, if x is bigger than 1, that means that denominator x minus 1 is a positive number. And if it is a positive number, of course, we can multiply both sides of the inequality by x minus 1 without the inequality sign flipping, can't we? And this gives a simple linear inequality, which if you solve it, 2x minus 2 would then be less than or equal to 1. So x then would be less than or equal to 3 on 2. You get that as your solution. So the solution for x that we get from this case is if x is greater than 1, then x must be less than or equal to 3 on 2. So in other words, x is in between 1 and 3 on 2, but it includes 3 on 2, doesn't include 1. Okay. Now in the second case, when x is less than 1, in this case the denominator x minus 1, that'll be a negative number, wouldn't it? Now knowing that it's a negative number, again we can multiply both sides by x minus 1, but this time we would have to flip the sign of the inequality, wouldn't we? Because we know x minus 1 is a negative number. Again, this yields another simple linear inequality that you guys can solve for x, and you get x greater than or equal to 1. Now, this case actually leads to a contradiction then. Why? Because we started this case assuming that x is less than 1, but the solution that we get is that x must be greater than or equal to 1. Of course, guys, x cannot be less than 1, at the same time be greater than or equal to 1. Okay. Now what's the implication from there? It just means that from this case we don't get any solutions. Okay. Then the only solution for x comes from the first case, and that solution was this, wasn't it? Okay. 11c done. Moving on to 11d, substitution. All right. So differentiate the expression that you are substituting to obtain du equal to negative dx. We also need to change the boundaries. So we have x equals to 1 and x equals to 0 as our upper and lower boundaries in the integral. And for each of those values of x, 1 minus 1, 1 minus 0 will be 0 and 1 respectively, wouldn't it? And then, now making the substitutions. So 1, 0, x, 1 minus x to the power of 10 dx will be equal to, the boundaries would flip. And of course, since u is equal to 1 minus x, well then x will be equal to 1 minus u, wouldn't it? I subbed in u into this x over here. And then the whole point, right, the whole idea behind this substitution is to change this 1 minus x into a u and the same power of 10, isn't it? Dx was negative du. The negative in front of the du can then be consumed to flip the boundaries back to 0 at the bottom and 1 at the top. I'm talking about this negative sign over here can be consumed for that. And then expanding 1 minus u multiplied by u to the power of 10, I got u to the power of 10 minus u to the power of 11, each of which are terms that can be integrated very, very easily, like that. And your upper boundary is 1, 0, so your final step of calculation, upper minus under, that's your upper when you sub u equals to 1. Under, you get 0 for both of them, so you don't have to write that. And sorry, it was a negative in the middle over here, wasn't it? So 1 on 11 minus 1 on 12 gives 1 over 132. Now, moving on to 11e, volume question. Find the exact volume of the hyperboloid created when the curve x squared minus y squared equal to 9 between the 2 points stated in the question is rotated about the y-axis. Well, then the volume of the solid formed by rotation is going to be given by pi times. Then your boundaries will just be minimum y, maximum y, wouldn't it? Because you're rotating about the y-axis. Now, what's the minimum y, maximum y? Well, here they are, 4 minus 4. Of x squared dy is your volume. Now, what is your x squared? Where do you get your x squared? You get your x squared by rearranging the function over here. And that gives 9 plus y squared, doesn't it? Or y squared plus 9. And you just integrate that. And it's upper minus under again. Okay? So quickly doing that. Y cubed over 3 plus 9y. In your HSC, guys, show the substitution if you can. In fact, yeah, just show the substitution. Like that. And then that entire expression, of course, can just go into the calculator. And you put that in the calculator. Then you get 344 pi over 3 as your volume. Simple, easy question. 12. Moving on to question 12. Question 12a. Polynomial has 2 of its roots equal in magnitude and opposite in sign. Right, and it's a polynomial of degree 3, isn't it? Meaning what? How many roots in total? 3. And of those 3 roots, 2 of them are equal in magnitude and opposite in signs, aren't they? So, how I can begin the question is I can begin by assigning appropriate pronumerals to describe these roots. Let the roots be alpha. Then the one that is equal in magnitude and opposite in sign, I can describe it as being negative alpha, can't I? And the third root, which I don't have information about, I'll just let it be beta. Given that, find the value of m. Okay, so it's a question that revolves around the relationship between roots and coefficients of a polynomial. Okay, I'm talking about things like the sum of roots which is alpha plus negative alpha plus beta, being equal to minus b over a, okay, where a and b are the coefficients of x cubed and x squared respectively. Now both of them are 1 for this polynomial, isn't it? So negative 1 over 1 would give negative 1, wouldn't it? And that means because alpha and minus alpha cancel, that means beta is equal to minus 1. Okay, and here guys is the reason why, right? They asked for the value of m, so you might question, oh, shouldn't you then begin by considering sum of roots taken 2 at a time, as in, shouldn't you consider alpha beta plus, beta gamma plus gamma alpha? Well, no, well, you could, I shouldn't say no, okay? You could, but I decided to go with sum of roots first because I knew that if you add the roots, then the plus minus alpha would cancel each other out, and importantly, it gives you a value for one of your roots. And what's the benefit? What's the advantage of knowing one of your roots? You can then go straight into subbing that into your polynomial. Why? Because that should equal to 0. Why? Because beta is a 0. Beta is a root, isn't it? And that means p of minus 1, which is what? Again, in your HSC, show your substitution. Negative 1 cubed plus negative 1 squared minus m times negative 1, negative 3, should equal to 0. And rearranging that equation just gives you m. It's equal to 3. So that's 12a done. 12b. Trigonometric transformation. Write 3 sine x plus root 3 cos x in the form r sine x plus alpha. Okay, so we know that r sine x plus alpha, by compound angle formula, is that. Okay, so what's the takeaway from that first line that I've written down? Takeaway is that with these trigonometric transformation questions, you begin from compound angle formula. Okay, and why did I put brackets around r cosine and r sine? Because the r cosine, okay, is meant to be my so-called coefficient for sine x, which needs to be 3 in this question. Similarly, r sine alpha is meant to be the coefficient of my cosine x, which in this question is meant to be root 3. Okay, so I can write them down. Like this. And you can solve these two equations simultaneously to find the values of r and alpha. Okay, I normally go straight to dividing the sine one by the cosine one in these cases, because the r's cancel in that case, and sine over cosine of course gives you tan. Root 3 over 3 is what I get on the other side. And of course for acute angle alpha, you see in the question it was stated that alpha is between 0 and 90 degrees, 0 and pi on 2 I should say. For acute angle alpha, the solution is pi on 6, isn't it? And yes, if you found the value of alpha, you sub this back into any one of the two equations. So r times cosine pi on 6 needs to equal to 3. And cosine pi on 6 is root 3 over 2. That means r needs to equal to 3 times 2 over root 3, which if you rationalize the denominator, you get 2 root 3. So having found the values of r and alpha that you need, you can then write this as 2 root 3 sine x plus pi on 6. And that is the end of that question. Okay. 12C got a projectile question. And object launched horizontally from point T, which is at top of a 45-meter tower. So we can see the 45-meter over here and point T at the top. And it's launched horizontally. And there's a 15-meter high wall that is 20 meters away from the origin. That's all shown in the diagram, isn't it? You guys can all see the 15 meters and the 20 meters as well. The vector displacement function, so in other words, this is the displacement vector, is given to us as well. And capital V is the initial horizontal velocity. T is time in seconds. Show that the value of V such that the object clears the wall must be greater than 20 over root 6. Okay. So the question is telling us, part I is telling us that the initial speed, the launch speed V, this over here, launch this way, it's basically telling us that it must be sufficiently big, right? It must be bigger than this number over here for it to clear the wall. Why? Because what's going to happen if it's not big enough, right? If it's not big enough, you guys can all imagine that the trajectory of the ball would look something like this, okay? And it would either hit the wall, okay, not go over it, or it won't even reach the wall in some if the V is too small, wouldn't it? Okay, so basically the question is telling you to show that in order for it to have enough speed to clear the wall, okay, the initial launch speed needs to be 20 on root 6 or greater. Now, how I can do that is I can as I have written down, I can investigate, okay, I can look into the displacement of the projectile when x is equal to 20. Okay, now what's the significance of that? X equals, that's when the particle over here, or the object, or whatever, projectile, okay, horizontally reaches the wall, isn't it? Okay, and x being equal to 20 means this Vt is equal to 20. So T is equal to 20 on V. What does that mean? It means that the object over here takes 20 over V seconds to reach the wall. Okay, and I'm going to look at what y is equal to at that time. Y, of course, given by 45 minus 5t squared. 45 minus 5 times. And as I just said, the time that I am interested in is at t equals to 20 over v, because that's when the ball, or that's when the projectile reaches the wall, isn't it? Sub that in. Squared. Do a little bit of simplification. 45 minus 2000 over v squared is what I get as what? As what does this represent? This is the y-coordinate. This is the y-coordinate of the projectile essentially when it has traveled 20 meters in the x direction. And of course, for the projectile to clear the wall, this y-coordinate would need to be greater than 15, wouldn't it? Why? Because the wall is 15 meters high. Okay? So then, the expression that I found, 45 minus 2000 over v squared, would need to be greater than 15. That's to clear the wall, of course. Rearranging that. 2000 over v squared must then be less than 30. Now I'm gonna flip the left-hand side around, or flip both sides around essentially. But when you flip the sides of an inequality, the inequality sign also flips. So v squared over 2000 is greater than 1 over 30. That means v squared is greater than 2000 over 30, which is 200 over 3. And now take the square root of both sides. V must then be greater than, and I'm sure it's, square root of 200 over 3 is equivalent to 20 root 6. I'm pretty sure it is. Let me just double check on my calculator. Yep, it is. They're equivalent to each other. So we do get the required to prove, don't we? Okay. Again, I'm not gonna show the surds, the algebra, the arithmetic with surds. Okay, I'm sure you guys can do that on your own, right? But yeah, that's the idea. Okay. There's a second part to the question which states that now if the object is fired from the wall with a horizontal velocity of 9 meters per second, it says, find the impact speed as it hits the ground. So they're giving you a value of v essentially. Okay, they're giving you a value of v. Again, the initial launch speed. They're telling you that that's equal to 9. Okay, and I'm sure this 9 is greater than the 20 over root 6 because it's probably gonna clear the wall, okay, in order for it to strike the ground over here, okay, and they're getting you guys to find the impact speed. In other words, the speed with which this projectile strikes the ground is what we have to find, given the value of v to be equal to 9. Okay, and in order for us to do that, okay, speed, we need some kind of information about the speed of this projectile, right? Speed or velocity, we know, is the derivative of the displacement, isn't it? So I'm actually going to begin the question by differentiating. The displacement vector, which for its I component, I would just get v. And for its j component, I would get minus 10t. Okay, that's the velocity vector of my projectile, isn't it? And given that the capital V is equal to 9, all I then need to know is I just need to find the time it takes for the projectile after it is launched. I just need the time it takes to strike the ground. Why? Because I need to substitute that time into the j component, don't I? Right? So for the j component, okay, I just need to find the time it takes for the ball to strike the ground. And in order to do that, again, the idea is the time when this ball or time when this projectile is on the ground is the time when its y coordinate over here is equal to 0, isn't it? Okay. So when projectile lands, its y coordinate is equal to 0. So 45 minus 5t squared is equal to 0. rearrange that. T squared is equal to 9t is then equal to 3. Of course, since t time cannot be negative over here. Okay, so what does that mean? It means it takes 3 seconds. It means it takes 3 seconds after the ball is launched to clear the wall and then hit the ground. It takes 3 seconds, right? And what is the velocity vector of the projectile at that time then? At t equals to 3? Well, it is 9, because we said that this capital V was given to be 9, and minus 30. Isn't it? 9I minus 30j, that's the velocity vector at t equals, now what does that mean? It means, guys, at t equals to 3, when the particle strikes the ground, its velocity vector, okay, looks like this. Looks like this. 9I minus 30j. Okay? That's what it means. And if they ask you for the impact speed, they are then asking you for the magnitude of that velocity vector, which will be given by square root of 9 squared plus 30 squared. And that, in the simplest third form, is 3 times square root of 109 meters per second. Okay? Next, 12D. Using polynomial division or otherwise evaluate. Okay, so for this one, I'll skip the polynomial division part, right? Because again, I'm just going to trust that you guys can handle the division on it. Basically, it's telling you guys to divide x cubed by x plus 1. Why? Because you literally have x cubed divided by x plus 1. Okay? And you should get some quotient when you do that division. And you should get some remainder when you do that division as well. Okay? And what does this mean? Again, it's the same idea from multis, isn't it, guys, right? Polynomial x cubed can then be written as divisor times quotient plus the remainder that you can find through the division itself, right? Such that x cubed divided by x plus 1, okay, your integrand, right, is equal to, if you divide both sides of that equation by x plus 1, it'll be equal to that quotient function that you would have found plus the remainder function divided by x plus 1. Wouldn't it? Okay, you'd be able to obtain that, and basically it's this that goes into the integral. Okay, and when you do that, you end up with x squared minus x plus 1, okay, because that is the quotient when you divide x cubed by x plus 1, and the remainder that you get is minus 1. So you get negative 1 over x plus 1. And the rest of it is simple, straightforward integration, isn't it? X cubed on 3, x squared on 2, plus x, minus the last one is ln, x plus 1. Because you have function below its own derivative. That calls for ln. And then again, upper minus under. So 1/3, half, 1 minus ln 2. And then the under, You get 0, 0, 0, and you also get, as your last time, you get ln1, but ln1 is also 0, so everything's 0 for the under. You don't have to put anything then. Just simplify this. You get a 5 over 6 minus ln2 as your answer. Okay? Now, question 12E, the last question for question 12 over here. Bag contains blue, red balls in the ratio 2 to 3. Ball is drawn from the bag, its color is recorded, and it is returned to the bag. This is repeated 25 times. Let x be the random variable representing the number of red balls. Okay. Then, guys, x is going to be binomially distributed because the question is about binomial distribution, right? And the number of times that this ball selecting process is carried out is 25, okay, which also becomes the value of my n. And each time the ball is drawn, the probability that it is a red ball is 3 on 5, isn't it? Why? Because the question told us the bag contains the balls in 2 to 3 ratio, where 3 represents the red, doesn't it? Yes, it does. Blue is 2, 3 is red, so 3 on 5 is the chance of you picking out a red ball, isn't it? And that becomes the value of P in this question. Given that, use the standard normal table on page 13 to estimate the probability that there are more red balls. More red balls drawn from, more red balls. You draw 25 balls all together. Now, then, in order for you to have more red balls than blue balls, you guys understand that you would need at least 13 red balls, wouldn't you? Okay, so in other words, the x, which represents what again? Number of red balls, must be greater than or equal to 13, doesn't it? And your job is to find the probability of this occurring. Okay? And again, we approximate this through the standard normal distribution, through the probability that the standard normal variable Z is greater than or equal to, okay, your Z score, right, number of standard deviations above or below the mean, that Z being above. Okay, what is the Z score then? On over here, I'm saying, what is the Z score of 13? Because Z score of 13 is what goes over here, right? But asking you for Z score of saying what is the Z score of 13 in this context is basically the same thing as asking how many standard deviations above or below the mean is 13. That's what I'm asking, right? Well, what's the mean? What's the standard deviation then, right? Mean, that's the expected value of x, is n times p. (15), and the variance n times p times q, or n times p times 1 minus p, which is equal to 6. That's the variance. Okay, those are formulas you learn in binomial distribution topic. Okay, and given that the mean, the expected value is so expected value of 15 over here means you expect to get 15 red balls when you draw 25. Why? Because chance of you drawing a red ball each time is 3 on 5. So if you do it 25 times, you expect on average to get 15 red balls, right? Variance, on the other hand, which represents how spread out your data is 6. Now, with that, Again, the question was how many standard deviations above or below the mean is the number 13? Well, then 13 sorry. The expected value 15 minus 13 then gives you the fact that, oh, sorry, I did it the other way around, didn't I? My bad. 13 minus 15. 13 minus 15, okay, which is just 13 minus the mean minus the average, right? Then gives you what? That's equal to minus 2, but what does the minus 2 represent? Minus 2 represents the fact that the score 13 is 2 below the mean, doesn't it? That's what the minus 2 represents, right? We also call that the deviation. Okay, just the deviation, right? The deviation of the score 13 is minus 2 away from the mean, right? Means what? 2 scores below the mean, okay? And when you ask for the z-score, right, what they're asking is then, well, then in terms of number of standard deviations, how many number of standard deviations is that? Well, the standard deviation is the square root of the variance. It's the square root of 6. So we can say that 13 is 2 divided by root 6 standard deviations below the mean because of the negative sign, okay? And this in the calculator gives approximately negative 0.82. Correct to 2 decimal places. And the rest of the job is now to just go to the standard normal table on page 13, they say. Okay, well, it looks like in this paper it was on page 13, but again, just whatever standard normal table you guys are provided with, right? Use the table, okay, to figure out what this is equal to, and then you're done with the question. All right, to question 13 we go. Another simple indefinite integral to solve or to find. Here we have sine x, sine 2x. Okay, so if you ever need to integrate whether it be sine A, sine B, which is what we have over here, or like, you know, sine A cos B, or cos A cos B, cos A sine B, or whatever. Okay, basically sine A cos B multiplied. Okay, product to sums. Go to your formula sheet if you need to. Product to sums. If you have it memorized, even better. Products to sums formula tells us sine A sine B is cosine A minus B, so x minus 2x, which is negative x, minus cosine A plus B, so x plus 2x, 3x. And then very, very straightforward integration follows. So the cosine minus x, well, cosine is an even function, so you can treat that as cosine x. And primitive of cosine x is, of course, sine x. Similarly, reverse chain rule for cosine 3x. Sine 3x over 3. Don't forget your plus constant. And this gives half sine x minus 1 over 6 sine 3x plus c. Alternatively, you guys could have done this particular example by applying double angle formula. to sine 2x, and then you get reverse chain rule after you apply double angle formula. Okay, so if I quickly demonstrate that, sine 2x is 2 sine x cos x so you get that, and as you can see, that's reverse chain rule. Why? Because you have cosine x, which is the derivative of sine x, isn't it? So I'm saying you get 2 sine cubed x over 3 plus c. I know these look different, but they're actually the same thing. Okay, if you apply trigonometric identities, like trigonometric functions, formulas, essentially, you will be able to prove that the two are the same thing, and both answers would have been accepted. Next, induction. Okay. Starting with n equals to 1. When n equals to 1, left hand side, when this n over here is equal to 1, you get your first term, don't you? 1 over 2 to the power of 1, which is half, right? 1 over 2. Your right hand side, 2 minus 1 plus 2, which is 3, over 2 squared. 2 to the power of 1. Which you also get half from. So therefore, left hand side equals to right hand side. The statement is true for n equals 1. Assume true for n equals to k. Is your second step of induction. So that means assume 1 over 2 plus 2 over 2 squared plus 3 over 2 cubed plus k over 2 to the power of k is equal to 2 minus k plus 2 all over 2 to the power of k. And then using that assumption, we prove the statement true for n equals to k plus 1, don't we? So for n equals to k plus 1, the left hand side would be equal to all of this plus one more extra term if n equals to k plus 1, wouldn't it? And that's going to be k plus 1 over 2 to the power of k plus 1. And of course, here we use the assumption where? On this part. From assumption, that part, so everything excluding the last term essentially is equal to 2 minus k plus 2 over 2 to the power of k. And we have the last term added. And essentially, we need to now simplify this algebraically, okay, to get, what do I need to get on the right hand side? The expression which I need to get on the right hand side is 2 minus k plus 3 over 2 to the power of k plus 1, isn't it? That's what the right hand side is when n is equal to k plus 1. So what would I do? I would leave this. That is, don't touch the 2 minus because I need it. And I would put these two fractions together with a common denominator of 2 to the power of k plus 1. Now that means the k plus 2 over here needs to be multiplied by a 2. The k plus 1 need not be multiplied by anything. And if you simplify that numerator, you do indeed get k plus 3. So you do get the required right-hand side. And with that, again, of course, in your exam, you would need to write a conclusion from that, wouldn't you? Okay. So, you know, by principle of mathematical induction, the statement is true for all integers n greater than or equal to 1 is what you would write down at the end of your proof, okay? Which, again, in here, I'll just skip, okay? Question 13C. Got position vector of P given, and that apparently lies on the circle x squared plus y squared is equal to r squared. That's a circle with center at the origin and a radius of r. And we basically have to show this, which again is a really straightforward question, to be honest, because the vector p minus a, we're given that vector p is p1, p2. Okay, and the vector a, given that the circle has a radius of r, that vector a, or the point A over here, you can describe the coordinate of that point A as negative r, comma 0, can't you? Which means vector A, which is the position vector of point A, is also negative r, 0. So in fact, if you do the vector p minus a, this should be a plus, shouldn't it? Double negative. Such that magnitude of that is then, or actually, magnitude squared actually, in the required to prove, is then p1 plus r squared plus p2 squared. Now similarly for p minus b, we do the same thing. P minus b, as you can see above, is that vector. Why? Because point B will have the coordinates r and 0, wouldn't it? So vector B would be r0 as well. Meaning the magnitude of p minus b squared is p1 minus r squared plus p2 squared. And what do they have in the required to prove? They have these two things added. Added. Which means what? Adding these two things, doesn't it? Adding those two things. So we end up with, well actually, I'll just copy and paste it first. I'll just copy and paste it first, and then I'll do the expansion. Which gives p1 squared plus 2rp1 plus r squared plus p1 squared minus 2rp1 plus r squared plus 2 times p2 squared. And 2rp1 cancel, and we have 2 times p1 squared plus p2 squared. But of course, p1 squared plus p2 squared should equal to r squared, shouldn't it? Why? Because we know that point P with this position vector lies on this circle. So if you substitute in the coordinates of point P, which is P1, P2, into the equation of the circle, the equation should satisfy. Okay, if you sub this in to x and y respectively. So P1 squared plus P2 squared should give R squared, shouldn't it? So 2R squared. And the reason why I don't have the 4R squared that I need on the right hand side is because I forgot to copy these down. I also had plus 2R squared, which makes the required 4R squared, doesn't it? And that is the end of question 13C. Okay. Now, moving on to question 13D now. So you have an expression given for the volume of water in this bowl, and h is the height of that water. And it tells you that bath of radius 0.5, I guess that's describing what the value of this R is. So given that R is 0.5, it's being filled with water at a constant rate of 0.03 cubic meters per minute. So this is the rate at which the water is being poured in. In other words, it's the rate of change of volume with respect to time. Calculate exact rate at which height of the water is increasing. Okay. So the rate that they want you to calculate is then rate of change of height with respect to time, which of course we obtain through we obtain through chain rule. dH dV multiplied by dV dt. Why? Because we had dV dt given in the question, didn't we? How do I get dH dV then? dH dV is obtained by differentiating this to obtain dV dH. If you differentiate both sides with respect to h, and dH dV is just the reciprocal of that, isn't it? So what I'm going to put is I'm going to put 1 over here, and I'm going to put the derivative of v at the bottom. Derivative of this v at the bottom. Okay, this v, by the way, is 1/3 pi 3rh squared minus h cubed, isn't it? I'm going to put the derivative of that at the bottom to take the reciprocal. And of course, I would end up with pi on 3, 6rh minus 3h squared. That multiplied by the rate of change of volume with respect to time, dV dt, 0.03, is what dH dt is equal to. Okay, and the question wants you guys to find what this rate's equal to for a bath of radius r 0.5 and h equal to, at the instant, that is, I should say, when h is equal to 0.25. So you sub in those numbers. Six times 0.5 times 0.25 minus 3 times 0.25 squared. And like I said, that You just put that in the calculator. And in terms of pi, you end up with 4 over 25 pi. That's in exact values, of course, isn't it? And they wanted you guys to find the rate in exact values. So yes, in terms of pi, 4 over 25 pi, the units here for rate of change of height should be meters per minute. Okay. And the final question of question 13.
Okay, to question 13e, graphed is the function f of x, which has the equation e to the power of x minus 2. First part, sketch the graph of f of absolute value of x. All right. This one, a fairly simple job where all that you have to do is keep the side of the graph for positive values of x, as in this part of the graph of f of x, which is shown to us in the diagram, we keep as it is. Get rid of the other side, that is, get rid of the side of the graph for negative values of x. Reflect what we have over here across the y-axis, like this. And we have the graph of f of absolute value of x, which I will label it as follows. And we're done with the first part of the question. I should label the y-intercept, which is given to be -1. Now, second part, on the same diagram, sketch the graph of the reciprocal of this thing which I drew, identifying all significant features. So I will draw the reciprocal function in a different color. To draw the reciprocal function, first of all, place vertical asymptotes at where you have the x-intercepts, at where you have got the roots or the zeros. That's because the reciprocal of a 0 is undefined, of course. Now, they did say identifying all significant features expressed in exact form. So they're actually expecting you to put down the equations of the asymptotes as well, or at least where it crosses the x-axis. They want you guys to write that down. So in order for us to do that, we would need to figure out what this 0 right here is. This, of course, is where e to the power of x minus 2 is equal to 0. You rearrange that so e to the x is 2. That means x coordinate of the intercept is ln 2. So I will put that down. Label that is. And of course, the other one over here, negative of ln 2 due to symmetry. Now, and then I will continue sketching the reciprocal function. Next is to note that this point, where y is equal to -1, and also these 2 points, where y is equal to 1, become your points of intersection, because reciprocal of 1 and reciprocal of -1 are 1 and -1 respectively, aren't they? So these are points that do not move. under your transformation, under taking the reciprocal. Next, we draw the sketch of the reciprocal function. And for that, we just note that when you take the reciprocal of number, reciprocal of a positive number stays positive, reciprocal of a negative number stays as negative. Now, in terms of the size of the number, when you take the reciprocal, big numbers become small, small numbers become big. Okay, essentially apply that characteristic which you guys have learned in your math course. Then on the very left, yeah, that's how the graph would look, like this. And on the right, you would have a symmetrical graph, which would look like this, passing through the point of intersection at y is equal to 1, which we have marked. And then in the middle over here, your reciprocal graph would have a sharp point at y equals to -1, because the original function also had a sharp point created when you reflected your graph. So there you go. That's how the reciprocal function would look like. And I will end the question by labeling that one as well. And then the last part of the question, hence or otherwise find the exact solutions to this equation. Well, in the previous two parts, you have sketched the graphs of these two. You've sketched the graph of the function on the left-hand side, you've sketched the graph of the function on the right-hand side. So what they're asking you in this part is they're asking you essentially to find the x coordinates of these points of intersection, aren't they? So the idea they're testing you, okay? The idea they're testing whether you guys know or not is essentially the idea that the solutions to the equation are x coordinates of the points of intersection. Between the graphs of f of absolute value of x, which is sketched in part I, and 1 over f of absolute value of x, which is sketched in part II, isn't it? And that said, one of the solutions is then really easy to identify. It's that one, okay? That one, of course, has got x coordinate of 0, and that'll be one of your solutions. Now, the other two solutions, which are represented by these two points of intersections, but remember when I was sketching the graph, I emphasized that what's common about these 2 points of intersection is that that's the point where y is equal to 1, isn't it? So what you can do is you can then put one of your graphs, and for the sake of simplicity, I'll pick this one, which has the equation e to the power of absolute value of x minus 2. Put that equal to 1 and solve for x to find the x coordinates of these points of intersection. Once again, that's of course because that's the point where y, f of absolute value of x, is equal to 1. So this would then mean e to the power of absolute value of x is equal to 3. Absolute value of x is equal to ln 3, which means x is plus or minus ln 3. And of course, the fact that we get plus or minus the same value as the solution makes sense because symmetry about the y-axis was one of the things which was emphasized during the sketching phase of the question, wasn't it? So yes, the three solutions to the equation are 0 and plus or minus ln 3.
Okay, to question 14 we go. 14a, points A and B have the position vectors given. Now find the projection of AO onto AB. The first question is a question that can be solved quite easily just actually by substituting numbers into the vector projection formula. So first of all, the vector AO, this would be the negative of the vector OA, whose components are given in the question. So vector AO would be -2, -1. And the vector AB, which we can find through OB minus OA. And of course, we have both OB and OA given in the question. So subtract the I components and subtract the J components. Vector AB would be, the I component would be -2, -2, so -4. 4 minus 1, 3. And there we go. Now we are ready to substitute these components into the vector projection formula. So the projection of AO onto AB, which is written like that, is of course the dot product of AO and AB over the magnitude of AB squared multiplied by the vector AB. And on the numerator, when I say the dot product, of course, I'm talking about x1 times x2. So -2 times -4, which is 8, plus y1 times y2. So -1 times 3, -3. Over the magnitude of AB squared, that will of course be 4 squared plus 3 squared multiplied by the vector AB, which was -4, 3. Now you can use the calculator to simplify this fraction down to 1/5 times -4 and 3. And that's the vector projection. Okay. Moving on to the second part, hence or otherwise find the perpendicular distance of AB from O. Now, in order for you to solve the second part, it is actually beneficial to have some kind of, or some sort of geometrical understanding of the situation in the question, as in it is very, very useful if you have a geometrical understanding of what the projection of AO onto AB that you found in first part is. So to illustrate my point, let me sketch on the Cartesian plane, guys, the vectors OA and OB first. Okay, so OA was 2, 1, or A was 2, 1, so A would be somewhere around here, I guess, and this would be the vector OA, O being the origin, of course, and the point B had the coordinates -2 and 4, so point B would be somewhere here, I guess. And of course, this would be the vector OB, wouldn't it? Right? And the vector AB then is, of course, the vector joining A and B, like this. And the projection of AO onto AB, okay, which you guys found in the first part. Well, AO is OA backwards, like I said, isn't it? Okay, so it's this vector joining from A to O. And the projection of that vector onto the vector AB is that's the perpendicular drawn from O to AB, and the projection is this right here. This right here. From A up to the foot of that perpendicular. Okay? And like I said, it is beneficial if you understand that that is the projection which you guys found in the first part. Okay? Why? Because what are we looking for in the second part? In the second part, guys, perpendicular distance of AB from O, we are looking for the length of this, aren't we? Okay, let me call that D. Let me call that D, right? And for the sake of convenience, if I label this point to be P, I'm essentially looking for the magnitude of the vector OP, aren't I? Or the vector PO. Either way, it works, right? And vector OP using head minus tail is going to be the vector AP, which I said is the projection, minus the vector AO, isn't it? So what? In the component form, that is the projection you found in part I minus the vector AO, which was -2, -1. Now subtract, collect the I components and the J components, and what you end up with is 6/5. And I believe, one second. You guys can just work this out in your calculator. Sorry. It's actually negative. No, it is 6/5. And yeah, 8/5. Okay. Yeah, sorry. It's just that in my notes, I had the vector the other way, as in instead of OP, I had PO in my notes, right? So I was just checking that, right? But it doesn't matter which one you use, because ultimately you're gonna find the magnitude of this anyways, right? So whether it be OP or PO, it's gonna have the same magnitude. Okay. So here I found the vector OP, and yes, components that you find by adding this. Okay. You guys can do that in your calculator as well, right? But yes, then the magnitude of this, the perpendicular distance, which is the square root of I component squared plus the J component squared, is then 2. Okay? And that is the end of question 14a. I'll now move on to question 14b. Now, this may have appeared confusing, but it really isn't. It's actually a really easy question. That, if I remember correctly, in the exam it was worth 5 marks, but it really shouldn't be worth 5 marks because the question is really simple. It's actually very easy. And the exam writer basically, whoever wrote the exam made the question easy. And what I mean by that is the writer made the question easy by essentially telling you guys and giving you guys everything that you guys need to solve the question. So all that students really had to do was to just substitute in numbers into the given integral over here. Substitute in numbers and substitute in expressions into that integral and just evaluate a definite integral. That's all that you really had to do. And 5 marks for evaluating a definite integral is a bit excessive in my opinion. But breaking down the question, cycloid is the path traced by a point on the circumference, blah, 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 blah. And then it says, guys, importantly, for a circle of radius r, it says it is described by the parametric equations, and they give you a parametric equations. Now, what's the it, right? What's the it? Of course, guys, it is referring to the path traced by a point on the circumference. In other words, the cycloid, right? The it is the cycloid, which is this thing that the diagram is showing, right? It's telling you guys that the equation of that thing called cycloid, right? Or just more easily, right? The equation of that path followed by a point on the circle is given by the parametric equations shown. Okay? So essentially what that means is that you pick any point. You literally pick any point on the cycloid. Okay? And each of these points have got x coordinate of r bracket theta minus sine theta and y coordinate of r bracket 1 minus cosine theta. That's what it is saying. And of course, different points on the path would just correspond to different values of theta, wouldn't it? And then it tells you that the arc length L of this cycloid can be calculated by evaluating this definite integral. And your job in the question is to find the distance in terms of r a point on the circumference travels in what? In one complete rotation. One complete rotation. Okay? That this point on the circle makes. Okay? And given, guys, that theta is the angle the radius to that particular point on the circumference makes with the vertical line, okay, as shown in the diagram over here, theta over here, right? You then should understand that when a particular point completes one rotation, theta would just be in the interval 0 to 360 degrees, wouldn't it? 0 to 2 pi, right? Because that's one complete rotation. Okay, so starting from, I'm saying theta, starting from 0, right, before the rotation begins, would reach up to 2 pi, okay, 360 degrees after one complete rotation. So all that you really have to do to find the arc length is to just change the boundaries in the integral over here, change these boundaries, so that it starts from 0, goes up to 2 pi, okay? And then evaluate your definite integral for that boundary. And the integrand is the square root of dx d theta squared. Now, what's dx d theta? Where do we get that from? Of course, it's just this thing over here, the x, differentiated with respect to theta, isn't it? Which would, of course, be r is a constant. 1. Now, sine differentiated, derivative of sine, cos. Oops. All of that squared. Plus dy d theta is obtained in a similar manner, similar way. You got, again, y as a function of theta given over here. So obtain the derivative of this to find dy d theta. And derivative of that, derivative of negative cosine would be positive sine. D theta. Okay. And then in the next step, if I expand this out, this thing in here, I get r squared as a common factor in the two terms, don't I? R squared, which, guys, of course, you can take the square root of it and then take it out to the very front, because r is just a positive constant that represents the radius of this circle. So r can come out to the front. And then under the square root, I have 1 minus cosine theta all squared, which if you expand, you get 1 minus 2 cos plus cosine squared. And of course, the sine theta squared, sine squared, isn't it? And what do we have in here? In here we've got cos squared plus sine squared, which of course would turn into 1. And therefore, you can write the expression inside the, you can write the expression under the square root as 1 plus 1, so 1 plus 1, so 2 minus 2 cosine theta. Can't we? And then the next step to evaluate this definite integral, I'm going to apply double angle formula. That is, in your formula sheet, you have something like this given. Sine squared theta is 1 minus cosine 2 theta all over 2. Okay, and what I'm making use of, right, what I'm saying is, under my square root, I essentially have this part. Yeah. So that part under the square root, you can change it into four times sine squared theta on 2. Okay. Again, if you don't understand the algebra, if you don't understand what just happened over there, right? Well, then, like I always tell you guys to, okay, you think about that yourself, right? Pause the video and think about that yourself, as in I've already told you that I applied this formula, okay? So you then think about yourself how the formula applies to this particular expression to change it into 4 sine squared. Okay, you think about it yourself. But now I have a perfect square under that square root. So I can remove the square root. and rewrite my expression like that. Okay, and I also know that I can do this, guys, because for the boundaries considered in the question, that is theta from 0 to 2 pi, guys, 0 to 2 pi, well, then this angle over here, theta on 2, would then be between 0 and pi, wouldn't it? Would then be between 0 and pi. Half of 2 pi, that is, of course. Okay? And the significance of that, guys, is for those values of theta on 2, which denote what? Angles in the first or the second quadrant. Sine theta on 2 will be a positive number. And that's important when I'm removing the square root. Okay? It is because sine theta on 2 is a positive number that I can say that the square root of sine squared is sine. Okay? Otherwise, guys, if sine theta on 2 was a negative, if it was a negative number, then the square root of sine squared theta on 2, I would have written that as negative sine theta on 2. Okay, but here we know it's a positive number, so we can remove the square root as I have just done. And then simple calculations follow after this to our primitive of sine is negative cosine, upper minus under. So cosine 2 pi on 2, cosine pi is negative 1. Cosine 0 is 1. And then you get 2 times 4, so 8r as your answer to the question. Okay? And if you look at the working out that I've done, right? Not even a page long. Okay? As I said, all this for 5 marks, probably a bit too much. Okay, and it's not like you guys needed to think a lot to analyze the question, because as I said, the question basically just gave you everything that you need, okay, to solve the question. You just had to put theta 1 and theta 2, the boundaries, as 0 and 2 pi, because that represents one rotation, one revolution, and then it's really straightforward calculation after that, isn't it? So yeah, that's the end of question 14b. Now moving on to question 14c, logistic question. Now question 14ci is probably the only question in this entire paper where you guys needed to sort of analyze the problem, and the question, in other words, requires a bit of thinking from the students. It's probably the only question from the entire exam, okay? Whereas every single other question is just no thinking, straight up calculations, okay? But yes, so we've got logistic equation over here. Looks like a typical logistic equation, yes. And it apparently the population P this time models the population of penguins in Antarctica. And it says in question I, in an ideal breeding season when the maximum growth rate occurs. Okay, for this guys question, let me begin by telling you guys, I guess a key feature, characteristic you could call it, or characteristic essentially of logistic functions that you guys can remember for your HSC, and it'll be useful when you happen to get a question that's similar to this, right? And the characteristic that I want to talk about, guys, is the time or the population at which maximum growth rate occurs for populations that are modeled by, or populations that follow logistic equations. Okay, and that is, if you look at the logistic equation, the growth rate dp dt, guys, is always given as, okay, so this is a characteristic, I'm saying, of all logistic equations. If you look at it, dp dt is given, guys, as a concave down quadratic function in P. Okay, that's a characteristic of all logistic equations, right? Meaning what? If I were to sketch the graph of the growth rate dp/dt against population P, it would look like this. And the two roots, or the two zeros of the parabola, guys, if you look in the equation for this particular example, it's one's at 0, the other's at 1000, isn't it? But yes, importantly, the shape of this graph is a parabola. That's the important fact. Okay, from which we can deduce what? From which, guys, we can deduce that this thing called maximum growth rate occurs at the vertex of the parabola, right here. Okay, at the midpoint, in other words, when the population is at the midpoint of your two zeros, isn't it? And based on that property, we can then say that for part I, dp/dt is maximum when P is equal to 500. Okay, and of course that's using the symmetry of a parabola, isn't it, right? And yeah, let me emphasize once again, guys, that is a characteristic of all logistic equations. Of course, depending on the logistic equation you guys get in your exam, the values for the zeros may be different, but yes, the maximum growth rate, maximum dp/dt occurs at the vertex then. Okay. And in this particular example, it occurs when P is equal to 500, like I just pointed out. And then it says, at this point, or at this time, or when the population is 500 essentially, all penguins in the colony find a mate, and half the penguin pairs successfully raise one chick. All penguins, so all penguins, that's what? All 500 penguins, all 500 penguins find a mate. So therefore what? So therefore there are then 250 pairs of penguins, or couples of penguins, you could say. Okay, 250 pairs, right? Because 500 divided by 2, half of which, so out of the 250 pairs, half, in other words, 125 pairs, of which raise one chick. So of course that just simply means you got 125 pairs of penguins, each of which raise one chick. So therefore there will be 125 new chicks at this particular point in time, wouldn't it? Okay, and what that also means is that if there are 125 new chicks being born, that also means that the penguin population grows by 125 penguins, doesn't it? In other words, the rate of growth, this maximum rate of growth of the population of penguins is 125, is what it means. Okay? So therefore, when P is 500, dp/dt is then 125. And that goes into the logistic equation over here. So 125 is R times 500 times 1000 minus 500. And if you rearrange that, you can find that R is equal to 1 over 2000 as required by the question. Okay? Yeah, and that's how that question could be done. So a lot of explanation needed to be done for this question, because like I said, this question was the only question that really required students to actually analyze and break down the problem and think on the spot. Okay, but all the other questions, as I said, are just straight up straightforward calculations, including the next part. Next part, guys, this is what I in my class always call it, the usual stuff, right? The usual stuff. Why the usual stuff? Because when you have a logistic equation, right, which you integrate that differential equation to obtain your solution curve, that is to obtain your equation for p as a function of time, right? It's the usual integration. It's the same integration that you guys do in every single question that involves logistic equations, isn't it? Right? It's the same integration every single time. Okay. So really, there's no reason to be confused about this one or get it wrong. Okay. So when I say the usual stuff, right, I'm talking about, okay, so you separation of variables. So you put all the p's onto one side like this, essentially rearrange the differential equation, right, times dp dt. Whoops. Equal to R. And here, yes, you integrate both sides now with respect to t. And of course, it is in here 1 over p times 1000 minus p that we can apply the given result. So integrate 1 over 1000 1 over p plus 1 over 1000 minus p. With respect to t, that's equal to integral of. Now we know from part I that r is equal to 1 over 2000, don't we? Okay. And about that, let me just quickly comment. It's a point that I have made before in the class, but about that, let me just comment once again, guys. Even if you were not successful in showing that r is equal to 1 over 2000 in part I, okay, you can in your HSC, right, just take it so that, assume so that you've done part I successfully and use the result of part I to solve part 2. That is okay. Okay. Now the reason why I emphasize this once again, guys, is I'm telling you guys, right? Just because you could not do the first part of this question, don't just give up, right? Don't just not look at the rest of the parts and just skip and move on to the next question, or don't do that, right? Do not do that. Why? Because like I just said, right? Even if you were not able to do the first part, you can still just get all the marks for the second part and the third part, right? And when you get a logistic equation question like this, guys, when you add up all the marks to each of these questions, right, it's worth a significant portion of your entire number of marks in your exam. Okay, like this question itself, right? If you add them all up, it'll be like easily like 7-8 marks altogether. Okay, so you don't want to throw away all those marks just because you couldn't do the first part. Okay, you can just use 1 over 2000 as your value of r in your second part to solve the second part, even if you couldn't show it in the first part. Okay. But yeah, anyways, then the 1 over 1000, 1 over 2000, they cancel. Produce the 2 over here. Dt also cancel. Now integrating the left hand side with respect to p, we end up with ln p plus minus ln 1000 minus p. And of course, on the right hand side, one integrator, you just end up with t plus, don't forget, c. And then applying log laws to the left hand side, 2 times ln p over 1000 minus p. Is t plus c. And at this point, let me substitute in the initial value given to me in the question to find the value of c. So I'm talking about how the question told us initially there's 200 penguins. So when t is equal to 0, population is 200. Substitute that in, so you end up with, on the right hand side over here, you have 0 plus c. On the other side, you got 2 times ln 200 over 800, which of course simplifies down to 1/4, doesn't it? So that means your function, your solution curve, your particular solution, you could call it, is given by that. Okay, and then from here, all that you have to do is just, do the usual algebra to make p the subject. So in order for me to do that, I'm going to collect all the ln's onto one side, all the logs onto one side, and then apply log laws. So again, I will then have 2 times log a minus log b essentially. Which gives me that. Divide both sides by 2 and then raise both sides to power of e to make this the subject, e to the power of 0.5t is what you end up with. And that of course means all of this is plus or minus e to the power of 0.5t. Take the reciprocal of both sides, so 1000 minus p over 4p is then plus or minus. And when you take the reciprocal of a power, you can just multiply the power by -1. Now, why did I do that? Because then the next thing that I'm going to do, I'm going to multiply both sides by 4 because I don't like the 4 down here. Then on the left hand side, I would have 1000 over p minus 1, p over p, giving 1, wouldn't it? And on the right hand side, I would have plus minus 4 times this. So what? So 1000 over p is then 1 plus or minus 4 times e to the power of -0.5t. And then again, take the reciprocal of both sides, so flip it around and multiply 1000 to both sides. So you end up with p equal to 1000 over 1 plus or minus 4e negative 0.5t is what you end up with. Okay, right above me, isn't it? Right above me is the expression that you end up with, right? Of course, that's not exactly the expression that they wanted in the question. They wanted, guys, plus, not the minus. Okay, they wanted the plus over here. Okay, so for that, all that you have to do is once again, use the initial value that they have given you. But what? P is equal to, but when time 0 population is 200, right? And then which one? Plus or minus satisfy that point, right? Plus or minus satisfy that condition, okay? It's got to be the plus, right? That's why the answer has got the plus sign. It's got to be the plus, right? When it is plus, so when t is equal to 0, when t is equal to 0, this e to the power of 0 would turn into 1. And you need, of course, guys, 1 plus 4. You need 1 plus 4 at the bottom on the denominator over there. You need 1 plus 4 is what I'm saying. So that 1,000 divided by 5, that's the 200 that we need, isn't it? So therefore, we can write our final solution without the minus sign. Okay, take the positive one that is now. Do I have to duck a little for you guys to see the actual answer above? I don't know, right? But yes, that's how the question is done. And again, it's the usual integration. Okay. Now moving on to the very last part, in the very last question. Then the question is part 3. How long to the nearest year will it take for the penguin population to reach 90% of the... So, okay. Maximum sustainable population. So again, let me begin this one again by telling you guys another characteristic of all logistic functions, and that is, it's this number here, guys. It's this number here that's essentially the maximum sustainable population. You also call it the carrying capacity in a lot of questions, don't you? That 1,000 in this example is the carrying capacity or the maximum sustainable population. Why? Because when the population P over here, when that reaches 1,000, guys, you guys understand that 1,000 minus 1,000, right? dP/dt would dP/dt would approach 0 as the population approaches 1,000, wouldn't it? And as it should when a population reaches its maximum carrying capacity, right? What does it mean to reach its maximum carrying capacity? It doesn't grow anymore. It doesn't get any larger, okay? Then the growth rate, dP/dt, should be 0, shouldn't it? Which, yes, occurs when P is equal to 1,000, right? Or when P approaches 1,000. So that number in that position right here, in this position right here, is always your carrying capacity for populations that follow the logistic equation, okay? And of course, when the penguin population reaches what, 90% of this maximum sustainable population, so that's 90% of 1,000, which is when population reaches 910, isn't it? And we need to find how long it takes, okay? So this that we got in the previous part, you put it equal to 900. And again, guys, for this part, let me emphasize, right? Okay, you know, even if you were a hella stupid, lazy person, right, and you know, that didn't really revise on how to integrate logistic equations, how to obtain solutions to logistic equations, you know, you were that lazy, right? Although it's the same integration, although it's the same calculation every single time, okay? So you just need to memorize, well, you just need to, you know, understand one, okay? And then you can just do the same steps of calculations for every other logistic equation. Even if it is like that, you know, you are hella dumb, lazy, okay, a stupid person, and you just didn't bother doing that, right? So you couldn't do part 2, right? Even if that was the case, well, you can still use the population model for the third part. Okay? Yes, but I hope that every one of you can find solutions to logistic equations. Okay? You can still use it for the third part, right? Just put it equal to, put the population that they have set equal to 900, and essentially just rearrange this to make T the subject. So then the denominator if you rearrange this, would be equal to 10 over 9. So that e to the power of 0.5t, this would then be equal to 10 on 9 minus 1, so 1 on 9 divided by 4, 1 on 36. Flip 36, half t, ln 36, t, 2 times ln 36, which of course goes in the calculator. And if I just put that in the calculator, 2 ln 36, you get around 7.17. Which to the nearest year, guys, is 7 years, isn't it? If you round that. Okay? Therefore 7 years. But you should also understand that because the population is growing, the penguins are growing over here. When you say 7 years, well, strictly speaking, after 7 years, the penguin population hasn't quite reached 900, has it? As in the question once, how long to the nearest year will it take for the penguin population to reach 90% of the maximum sustainable population? Well, if you say after 7 years, right? Like I said, after 7 years, it hasn't quite reached 90% yet. Okay, it's actually after 8 years that the if it's after 8 years, the population, yes, would be over 900. It would be bigger than 900. So it's sometime between 7 years and 8 years that the population reaches 900. Okay. So my opinion, in other words, is that the answer should be 8 years, is my opinion. Okay, because otherwise, like I said, if you say 7 years, then actually change my thought. I think it doesn't really matter. Either one works. You could make an argument, I'm saying, for either case. Okay, is my point, right? But yeah, to the nearest year, 7 years then. Okay, whatever. Because like I said, whatever. You could potentially make an argument for both 7 years and 8 years for this question, in my opinion. Okay, but anyways, yeah, that's the end of the CSSA paper. Okay, and before I end this video, if I were to just leave a few comments about general comments about the entire paper, I could probably call this paper, guys, one of the easiest extension 1 papers that I have seen ever since I started teaching. Okay, and let me tell you, I've had a look at, guys, a lot of past papers. Okay, whether that be HSC past papers or school past papers, right? But compared to them, this probably is one of the easiest papers that I've seen. Okay, in the sense that pretty much every single question did not require students to analyze the problem or break down the problem or think about the problem. Okay, the question itself essentially just gave all the things that you guys need in solving the question. Okay, and all that students really had to do was to just use what was given to them. Okay, and just perform calculations, right? So each and every single question was essentially calculation after calculation after calculation after calculation, right? Which is what I think makes this paper easy, at the same time not a very good reflection of what the actual HSC is going to be like. Okay, because in the HSC, of course, guys, HSC will also have questions that are just simple, pure calculations, right? Here's your information, calculate this, right? HSC will have that as well. But when you get to question 13 and 14 of the HSC, those questions will require students to analyze the problem. Okay, as in they have to think and search in the question to actually find the information that they need, right? Or it'll require students, question 13 and 14 of the HSC, that is, it'll require students to sort of think outside the box and come up with creative ideas in the question. Okay, and again, this particular paper lacked in that creativity sense as well, because every question, in my opinion, was very typical. Okay, so yeah, I got nothing else to say. Let me end the video. See you guys in the next one.